بسم الله، الحمد لله، والصلاة والسلام على رسول الله. الطلبة الأعزاء، السلام عليكم ورحمة الله وبركاته، وأهلا ومرحبا بكم في هذا الجزء السابع من المحور السادس لمادة Theory of Machines، والذي بعنوان Gears. I will present here some features related to reverted gear train. When the axis of the first gear or first driver and the last gear or the last driven or follower are coaxial, then the gear train is known as reverted gear train. As shown in this figure, here we have the first driver. Okay, gear number 1. It is coaxial with the gear number 4, which is the last driven or follower. We see that gear 1 drives the gear 2 in the opposite direction here. Okay, this is gear 2, this is gear 1. Since the gear 2 and 3 are mounted on the same shaft, therefore we have gear 2 and gear 3 are mounted on the same shaft. Therefore, they form a compound gear, and the gear 3 will rotate in the same direction as that the gear 2. Gear 3 drives the gear 4 in the same direction as that of gear 1. Okay, so gear 1 and gear 4. Thus, we see that in a reverted gear train, the motion of the first gear and the last gear is like. Let Z1 is the number of teeth on gear 1. R1 will be the pitch circle radius of gear 1, and N1 is the speed of gear 1 in RPM. Similarly, for gear number 2, 3, and 4. Since the distance between the centers of the shafts of gear 1 and 2 as well as gear 3 and 4 is the same, therefore R1 plus R2 should be equal to R3 plus R4. Here we have R1 plus R2 is equal to R4 plus R3. It is the same. R1 plus R2, it is equal to R3 plus R4. Also, the circular pitch or module of all the gears is assumed to be the same. Therefore, number of teeth on each gear is directly proportional to its circumference or radius. We'll find Z1 plus Z2 is equal to Z3 plus Z4. Let's see for this second equation how it is found. We know that the pitch circular pitch, P is equal to pi R into Z. It is equal pi M. Then R will be equal mz over 2, where M is the module. For each gear, we can find R1 is mz1 over 2, R2, and similarly R3 and R4. From the first equation, which is R1 plus R2 is equal to R3 plus R4, we substitute here mz over 2 for each gear, and by cancelling m and 2 here, we can find out z1 plus z2 is equal z2 plus z4. Z1 plus z2 is equal to z3 plus z4. Here we'll find the speed ratio. Is this the product of the number of teeth on the drivens divided by the product of the number of teeth on drivers. So the speed ratio, it is the speed on the first gear divided by the speed of the last gear. It is equal the product of the number of teeth on the drivens. So the drivens here are number 2 and number 4 divided by Z1 multiplied by Z3.